Hi everyone, this is the video for day 88. Remember I switched the order a little bit. Please make sure you put last night's homework onto Google Classroom so you get credit for it. And again, all of these worksheets are on my website, mrsrumbos.weebly.com. All right, here we go. So today we're talking about something called average rate of change. And rate of change, that's fancy for slope, okay? And we know our slope formula is y2 minus y1 over x2 minus x1. So now that is actually the formula only slope for a line. So slope only for a line. What we're going to learn today is kind of how to do the average change or slope of a curve. And the other thing you need to know before we start, which you already know, f of x equals y. So here we go, average rate of change. So find the average rate of change for the following problems. Show your work. So the average rate of change of function y equals f of x over the interval. Okay, remember, this means including. Okay, those brackets mean including. So is f of x2 minus f of x1 over x2 minus x1. So you did see me write this on the homework a couple of nights ago, and I said I would teach it to you, and here it is. So don't get too upset about it because it's really not that bad. It is really just what you guys know as slope. Okay, you know that f of x is just fancy for y. So f of x2 should be fancy for, well, y2. But look, that's what it is here, y2. F of x1, well, that's just fancy for y1. Look, it's the same thing here. And then on the bottom, x2 minus x1, well, that's the same. So it is really essentially the same exact thing as you know as regular slope for a line, but they have f of x2 minus f of x1 instead of y2 minus y1. Well, why do they have it? Why is it different? Because again, this is really only supposed to be used for a line, where this could be used for any kind of curve at all. So instead of y2 minus y1, it's f of x2 minus f of x1. But if you know that f of x is equal to y, then you should have no problem with this whatsoever. And they definitely always ask average rate of change on the regions. So before I forget, you have to use this formula. Okay, this is not okay for average rate of change. I need to see this if it says average rate of change. Thank you. All right, so here we go. Question number 1. Graph the following. All right, so you know this is a quadratic. You know it's going to be a parabola because of the squared. So you know that we need a table. So into our calculator, x squared plus x minus 2. And we're going to go to the table. We're going to look for that symmetry. And we can only go up to 4. And if we notice, we're missing something. We're missing the vertex. You're missing that middle number. So let me copy what we have so far. Negative 3, 4. Negative 2, 0. Negative 1, negative 2. I'm going to skip a space, okay, because again, when you have the repeats, that's where the vertex should be. And then we have 1, 0, and 2, 4. So the algebraic way to get this is negative b over 2a, okay, negative b over 2a. So that would be the negative of 1 over 2 times 1, which is negative 1 over 2, which is negative 0.5. So I know this is going to be negative 0.5. And then you just fill it in here to get the y. So after I fill it in here, I get negative 2.25. Remember, the other way to do it, the non-algebra way, is second window. Change this to 0.5. Go back to your table and now look in between negative 1 and 0. So I'm going to look in between negative 1 and 0, and I get negative 0.5 and negative 2.25. So I'm good to go. To change it back, don't forget, second window, 1. So that's a good skill to know for the regions, especially because I can't answer your questions on the regions. Okay, so a negative 3, 4, negative 2, 0, negative 1, negative 2, negative 0.5, negative 2.25, 0, negative 2, 1, 0, and 2, 4. Okay, we have a parabola. I was not given constraints, so you should be putting arrows, and you should write the equation. F of x equals x squared plus x minus 2. All right, done. Now let's plot these points so we had this graph, which, oh, that's kind of sloppy, sorry. So now we have 2 points, 2, 4, and 0, -2. So those points right there, they want us to graph it and draw a line segment connecting those. So now we have a line. Okay, so we have a line and we have a parabola. What's the slope? So slope we know of a line is rise over run, or you can use this formula. Okay, rise over run. 1, 2, 3, 4, 5, 6 over 2. 6 divided by 2 is 3. So 6 over 2, which is 3. Using the formula for average rate of change, so f of x2 minus f of x1 over x2 minus x1. And yes, of course, you have to memorize it because as we know, the Regents doesn't give you any formulas. Okay, so notice that they're giving us two values. The value that comes first is x1, right? X first, x1. The value that comes second is x2. So they want you to find the average rate of change from 0 to 2. So now instead of looking at the line, what you're going to do is get the average rate of change of this curve. Okay, so we're going to write f of, okay, well, what was the second x value that they gave us? Well, the second one was 2. What was the first x value they gave us? Well, that was 0. What was the second and what was the first? What's nice if you notice the numbers that are right on top of each other should be exactly the same. 2, 2, 0, 0. Okay, so now f of 2. What's f of 2? Well, you just kind of practiced this on your homework last night. Okay, you practiced it on your homework, getting values from a graph. So when f is 2, or when x is 2, what's f of 2? What's the y value? Well, that's 4. Okay, so remember this is the y value when x equals 2, and that's why I had you practice that last night. 0 is going to be -2, so 4 minus -2, be careful the minus negative, and then 2 minus 0. So 4 minus -2 is really 4 plus 2, which I believe is 6, over 2, which is 3. Oh, look at that. It's the same exact thing. Well, that's kind of what this exercise was showing you, that these really are the same exact thing, okay? And I know, again, well, why can I just use this one? Because it's only for a line. This has to be used when it's for a curve. But essentially, they really are the same exact thing, as you could tell from the numbers. All right, so now that I showed that to you, now let's actually practice. And it's really not bad at all. I'm just going to show you all the different ways that they could present the two values that they want you to use. And again, this was one where they had a graph, and we're going to do one that have a table, one that has nothing. So that's kind of what I'm going to show you. And this is not too bad at all. All right, so here we go. Average rate of change of y over the interval from x equals -1 to x equals +1. So this is going to be your x1, and this is going to be your x2. It's very important. You have to always know what your x1 and x2 are. Okay, so write your formula. F of x2 minus f of x1 over x2 minus x1. It's always good to write the formula because the more you write it, help you memorize it. All right, so x2, what was x2? That was 1. So f of 1 minus f of -1 is 1 minus -1. So this is x2, this is x1, this is x2, this is x1. So f of 1. So I'm going to go to this table. Okay, all three of these are off this table. So when x is 1, remember the number inside is x. When x is 1, what's the corresponding y? Well, it's also 1. When x is -1, what's the corresponding y? Okay, -1 again. And then copy this over. Copy 1 and -1. And now just simplify. 1 minus -1 is 2. 1 minus -1 is 2. And that gives us a value of 1. That's not that bad. Okay, number 2, average rate of change. We're still using the table, but now look. Now they give you the numbers that they want you to go from in an inequality form. Who cares? It's still not bad. That's your x1, that's your x2. It's all you have to know. So f of x2 minus f of x1 over x2 minus x1. So here we go. x2 is 1 and x1 is -2. So x2 is 1 and this is negative. Again, notice those are always going to match. Okay, now you got to figure these out first. You have to figure out what f of 1 is. So f of 1 is 1, and f of -2 is -8. So that's 1 minus -8, and I copy the bottom. 1 minus -8 is 9. 1 minus -2 is 3. 9 divided by 3 is 3. Okay. And now they're going to give it to you in integral notation. Who cares? We got this. x1, x2. So f of x2 minus f of x1 over x2 minus x1. So f of 2 minus f of -2. x2 is 2, x1 is -2. Okay, so let's figure these out. What is f of 2? So when x is 2, the corresponding y value is 8. And then we have -8, and we copy the bottom. That's going to give us 16 over 4, and that's going to give you a value of 4. So we have one average rate of change that we did from a graph. We have one average rate of change that we did from a table, and now we're going to do one from an equation. So this is your one that's going to be a little bit more work than the rest of them. You know the Regents, you know they love work. All right, average rate of change. They're going to give you the given interval, and this time they give us an equation. Remember, this is x1, and this is x2. So we start filling it in. F of x2 minus f of x1 over x2 minus x1. And then we have f of 5 minus f of 2 over 5 minus 2. All right, so now we have to figure out, well, what's f of 5? Well, how am I supposed to figure that out? I don't have a table, I don't have a graph, I don't have anything. Okay. So what you're going to do is you have one of two choices. So I guess I will show you both. So the first thing you could do, which most of you are going to do, create your own table. Where do I get the table for this? Well, that's what this is for. So go into y equals and put in 4x plus 3. So remember, these are your constraints. Okay, I haven't used that word yet, but you guys have seen these before. I've given these to you. So you're only going from 2 to 5, and that is it. So only copy from 2 to 5. So 2 is 11, 15, 4 is 19, 5 is 23. Okay, so you need this work to fill this in. Okay, now how else can I do it? The other way, a little bit more work, is you have to plug into here. Okay, what do I mean by that? So f of x equals 4x plus 3. So we're going to do f of 2 equals 4 times 2 plus 3, which is 8 plus 3, which is 11. And now I have to figure out the value for the second one, f of 5. So, nope, that's not right. F of 5 equals 4 times 5 plus 3. And that is f of 5 equals 20 plus 3. And f of 5 equals 23. Okay, so as you can see, f of 2 we knew was 11. F of 5 was 23. So there's two different ways to get the same information, but you have to show work. You need the supportive work on how to get this right here. So f of 5 is 23, and f of 2 is 11, and that's 12 over 3, which is 4. So 5 minus 2 is 3, and that's 23. Good. F is 4. Good. So you need some sort of supportive work. It's up to you. Either you just, copy the table from those two numbers, 2 to 5, or plug in. It's completely up to you. All right. Hopefully that was not too bad. Next page. So next page is going to be more of, I guess, like a word problem kind of thing, but no LS&C. Don't worry. Don't freak out. Okay. Average rate of change in a library between 2010 and 2013. Again, anytime you see this in a word problem, you must do f of x2 minus f of x1 over x2 minus x1. The Regents does not want to see the y2 minus y1. Okay, those are important because those are your, constraints from this number to this number. So 2010 is right here, and 2013 is right here. So I have my table. I don't have to go searching for it, anything like that. So x of 2 was 2013. So f of 2013 minus f of 2010 over 2013 minus 2010. So when x is 2013, so when the year is 2013, my population is 20,870. f of 2010. So when x is 2010, right, because you assume this is x and this is y, 16,988 over 2013 minus 2010. So we have 20,870 minus 16,988, and that's going to give me 3,882 over 3, which is 1,294. So that's 1,294. What do we got? What do we have? Dollars per year. I'm going to write. That sounds good. All right, number 5. Average rate of change. Let me zoom out a little bit. Average rate of change that represents the amount of money in the savings account. Okay, so where's my X1 and where's my X2? So they don't tell me. So what do? So if they don't tell you, use the first 2. If it doesn't specify the X1 and X2. Okay, so you can use the first 2 if it does not specify. Usually it does, but this is, one of those just in case. So our X1 is going to be 1 and our X2 is going to be 2. So here we go. F of X2 minus F of X1 over X2 minus X1. So now we have F of 2 minus F of 1 over 2 minus 1. F of 2 is 142. F of 1 is 128. And that is 14. 142 minus 128, 14 over 1. And that's going to be $14 per week. All right, so hopefully that was not too bad. So now we're going to kind of switch gears a little bit, but not really. There's something else they kind of ask with average rate of change. They just kind of ask it in a different way. It's more like back to like the slope and almost like an 8th grade thing. But they love to ask this on the region, so we have to go over it. So when the average rate of change of a function is constant, remember constant means the same, the function is linear. So I kind of said it the other day, and that's just basically a line. You only go up 1 over 1, up 1 over 1, up 1 over. You constantly are doing the same exact thing, constant. That's how you produce a line. Okay. Determine if the following function is linear by examining the average rates of change. So this is actually something that I do with the other group, my regulars. So, and what we do is we do change in y over change in x. Okay, and then what I let them do is I let them make little lines like this. So from -3 to 1. So think of a number line. How do I go from -3 to -1? So do I have a number line? Oh, we'll just use this. So how do I go from -3 to 1? I would add 2. So I'm going to put a +2 on top. How do I go from 1 to 0? That's 1. How do I go from 0 to 4? That's +4. And now do the same exact thing with the y values. From 6 to 2 is -4. 2 to 0 is -2. 0 to -8 is -8. So now what we do is we create fractions. Y over x, right? That's your slope. Change in y over change in x. So for this first one, it's going to be -4 over 2. What does that get you? -2. Then we have -2 over 1. What does that simplify to? -2. Don't assume the last one's the same. -8 over 4. Oh, but it's -2. So see how these are all the same when I go through this process? Because they're the same as constant, that means this function is actually linear. So it is linear because the rates of change are constant. Okay, and I'm actually going to show you something in a little bit on how to do it in the calculator. I actually get it to graph it so you could see what it looks like. So this is what 8 regulars have to do. This is what you probably, would have maybe done last year in class. But because you're in the regions class, it doesn't stop there. We don't stop at linear. We do everything else. So next page. Let's go over all of this now. So for the following tables, decide if they are, so linear, that's the one we just did. Again, that was constant rate of change. But now we're adding in quadratic, cubic, and neither. So we're going to basically do that same concept we just did with, like, you know, the counting on the side and making fractions and stuff like that. But it's just going to be a little bit more complicated because we have quadratics and cubics and stuff. Okay, so really quick, ROC, rate of change, is constant. So this is how I like to remember it, okay? Linear is always x to the first power. Quadratic is x to the second. Cubic is x to the third. That should make sense. So this one tells me the rate of change is constant on the first time or first try. This 2 tells me that it's going to be quadratic when the rate of change is constant on the second time. Okay, this is like my little shortcut, helps me remember. And then cubic, 3, when the rate of change is constant on the third time, and this will all make sense in a little bit, that's how I know it is going to be cubic. Okay, this is a little trick that helps me out. And then neither is not constant at all. And basically, if it's a neither, it's usually one of 2 other types. It's either going to be exponential or it's going to be absolute value. It's usually one of those 2 if it is not, if it's this neither. You never have something that's constant. So now I'm going to show you a shortcut, kind of like what I did on the previous page, but you have to know that this shortcut only works when the domain increases by 1. So if these numbers here on the side, remember domain is x, if they don't go up by 1, then you have to go through like this whole process where you're getting the difference each time and then getting your fraction. So this way is a little bit easier. It's a little bit of a shortcut, even more than that. All right, so xy. So of course I gave you everything that went up by 1. So I could show you how to do the shortcut. Okay, so you're going to make your arrows or your carrots just like before. So from 1 to 3, you add 2. From 3 to 5, I add 2. 5 to 7, I add 2. 7 to 9, I add 2. 9 to 11, oh, I add 2. So if you notice, our first trial, all of them were exactly the same. So think, so which one of these is first? Which one of these is x to the first? Well, that is linear. So so it's linear, and yes, you need an explanation, because the rate of change is constant on the first try, or it has a first common difference. So it is completely up to you which one you want to memorize. So because it was the first one we did, it was this first trial that we did, and they were all the same, that's linear. So you have to say rate of change, you have to say constant, you have to say first try. If you don't like that, just say it's linear because it has a first common difference, okay, or a common first difference, something like that. All right. Okay, so those. Now here we go. So from -7 to 0, you added 7, right? -7 plus 7 is 0. So from 0 to 1 is +1. So I automatically know right away. See how that's different? You know the first time is no good. It's not constant, so you know it's not linear. That's out. But you have to keep going. So that is 1. Then we have 7. And then we have 9. Okay, but now you have to keep going. 7 to 1, subtract 6, add 0, add 6. Notice how this is different on the second time. So we know it's not quadratic because the second rate of change is not constant. So that's out. But again, keep going. We got to keep going. Oh, by the way, this is 19, not 9. That's 19, and that's going to get us 12. Okay, last one. Let's see if it works this time. So -6 to 0, 6. And look at that. Oh, constant on the third time. So which one was third? Which one's got the 3? That is your cubic. So here we go. It is cubic because the rate of change is constant on the third try. Third try, third time, something like that. Or if you like the other explanation, it has a third common difference. Okay, whichever one you like, whichever one you want to memorize, it's up to you. Okay, so let's keep it going. Hopefully this is not too bad. Next one. Again, notice they all go up by 1. That's how I can use this little bit of a shortcut, little bit of a trick. So 8 to 3 is -5. Then this is -3. Okay, so there you go. It's not linear. It's not the same on the first try. The rate of change is not constant on the first try. Let's try again. So -5 to -3, I think, is +2. -3 to -1 is +2 again. And oh, look at that. It is constant on the second try. So which one was second? Well, that is quadratic because 2 is the exponent. So quadratic because the rate of change is constant on the second try, or on the second time, trial, whatever you want to say, or it has a second common difference. Second common difference. All right, moving right along. +1, +1, +1, and +1. -1, -1. Oh, looks like it's going to be linear. Oh, no, it's not. +1. No good. Okay, +0, +0, and +2. Okay, so quadratic is out. +0, +2. Oh, well, cubic is out. So this is going to be that last one. This one's going to be neither. So it's going to be neither because the rate of change is never constant. That's what you want to write for neither. Rate of change is never constant. Okay, so this would be the point in class where I would normally ask you, okay, well, look at the table. Can you tell me if it's exponential or absolute value? So hopefully you would see that all the negatives went to positives and all the positives stayed positive. So this is actually absolute value. If it was going to be exponential, when we did our exponential day, we talked about doubling and halving and tripling, things like that. So you would see that these would exponentially grow. That's how you know it's exponential. All right, last one on this page, a little bit of a word problem. Joseph conducted a science experiment involving the growth of bacteria. Ding, ding, ding. You see the word growth, you see decay, you are thinking exponential. Okay, but let's just see if I'm right. He measures the number of bacteria hourly for 6 hours. The data is summarized in the accompanying table. What type of regression? We're going to get to that in our stats units. I'm going to say that like 500 times in the stats unit, so we will get there eventually. Okay, +1, +1, +1, +1. So we have 100, 200, 400, 800, so not linear. Then we have 100, 200, 400, not quadratic. Okay, so I'm guessing it's going to be neither because I don't even see cubic here. So the third one's no good. All right, so is it absolute value or is it exponential? Well, I don't even see any negatives. And are these numbers? Nope. Okay, so you know it's going to be exponential. Now look at these. 100, 200, 400. What's happening to those numbers? They're doubling. The y values are doubling. Y values are doubling. So, and that's how you know for exponential. You're looking if it's doubled, tripled, halved, etc. So really, you don't have to do any of this work at all. You don't have to do this, you don't have to do this. If you just analyze the y values and you see that they're doubling, tripling, halving, whatever, it's automatically exponential. Okay, it is automatically exponential. So, All right, so there's one more question on the back. Before I get to that, I actually want to go over, you'll see I wrote the calculator check for the problems on this page right here. Okay, so I'm actually going to show you how you could put these into the calculator. This is brand new for us, and I wasn't planning on teaching it over a video, but it is what it is. Okay, so just kind of try your best to follow my notes. This is going to be a great tool, a great thing. You're going to use it all the time. So you're going to go to Stat 1. That will get you L1 and L2. Okay, so Stat is the button right below Delete. Stat. Now this is what's going to pop up. We're going to do this a ton in our stats unit. Then you're going to go number 1. And then this is going to pop up. Okay, now I already have numbers in here from last year. If you need to get rid of numbers because you have them in there, you go to the top. So I pressed up, and you have to press clear. Only clear. No press delete, only clear. And then it doesn't clear until you press down. Now I'm going to move over to L1, go to the heading, go to the title, the top, press clear, and go down. Okay, now it says put numbers into L1 and L2. Press enter after each number. So let's try this one. So all your X's are going to go in L1. All your Y's are going to go in L2. So we have -1. Remember, make sure you press enter or it doesn't register in there. 0, 1, 2, 3, 4. So -1, 0, 1, 2, 3, 4. Good. Always check. And then we have 1, 3, 5, 7, 9, and 11. Okay, now what we're going to do is we're going to turn on our points. We're going to turn on our points. So to do that, you're going to press the second button. And you can press Y equals. I want to go there where it says stat plot. Stat, oops, you can't see this. Stat plot. So Y equals. And you're going to go to number 1. And you want to turn it on. And that should be highlighted. Okay. And then you can, actually, I actually want to show you a little shortcut, actually. I just thought of something. There's another way to do this. If you go to Y equals, and you see these up here on top, sometimes when you guys bring me your calculators because you say they're not working, it's because this is highlighted. So if you go to Y equals, and I press that plot 1, you'll notice that now that's off. And if I go back to second Y equals, what I told you to go to, that is off. So if you don't want to go through this process, go to Y equals and press enter, and that stat plot will be turned on. Once it's turned on, you want to press zoom and number 9. So zoom is right here in the middle. Number 9, it's going to say stat because usually we do this in the stat unit. And then, okay, so what does this do for you? Oh, sorry, my other line is there. Let me get rid of that. If you look at those dots, what do they look like? Well, it should look like that it's making a straight line, which is what it is, linear. Okay, let's try another one. So again, you're going to go to stat. Okay, you're going to go to stat, and you're going to go to number 1. Nope. Stat 1. Clear out what you have in there. Again, you go up to the top and you press clear, and you press down. And now I'm going to copy this table. So -2, enter, -1, enter, 0, enter, 1, enter. Move over, and I'll put 0, 1, 2, 9, and 28. That's a 20, 28. And be careful, it's easy to make mistakes on this, so check it always. -7, 0, 1, 2, 9, especially on the regions. Always make sure you check. Okay, so now you can skip turning on the stat plot. It's already on, and I'll make sure we turn it off before we are done. So you want to press zoom, and you want to press 9. Zoom 9. And what this is it's curving this way and then curving up. So that was our cubic, which is what that is. Right, next one on the list. So I'm going to go to stat 1, -3, -2, -1, 0, 1, and then 8, 3, 0, -1, 0. Good. And you want to press zoom 9. And this one, you kind of see, looks like quadratics. So again, this is just the way to, one, check your answer, and two, kind of get the answer without doing any of the work if it's multiple choice. But sometimes I think they're a little hard to see and figure out, especially like a cubic one. So I'd rather do the work anyway, but that's me. Stat 1. Okay, let's do this one. So we have -3, -2. Oh, it was same numbers. I could have got them in. 0, 1. And then we have 3, 2, 1, 0, and 1. So if I do zoom 9, you'll see the V. Again, the V is the absolute value. Okay, and even this last one works. Stat 1. Again, up to the top, press clear, and press down. It won't go away until you press down. I have no clue why, though. 100. Nope, that's 10. 100, 200, 400. Okay, zoom 9. Zoom 9. And that, again, look, only the first quadrant. Only the first quadrant. We know that's going to be our exponential. All right, so to turn this off, you have two choices. Second y equals, and go to off. Or I'm going to turn it back on just to show you the other way. If you go to y equals on top, just press that and it'll unhighlight it, and then that turns it off. Okay, so that is how to do that on the calculator. A lot of kids like that. Hopefully that helps you. All right, last question, last one. This is a long video today. Last one. Sorry. Okay, so you're given this function. It wants us to do average rate of change from x equals 1 to x equals b. And find about the average rate of change. I think it's supposed to be if. If f of x from -1 equals 12. Okay, that makes more sense. Okay, so this is your x1. This is your x2. Here we go. F of x2 minus f of x1 over x2 minus x1. So x2 is, oh, this is weird. It's a letter. Okay. F of b minus f of 1 over b minus 1. Oh boy. F of b. Okay, so this is like before. I don't have a table, a graph, and to look at, so I would go to my calculator. But the problem is I can't put b in the calculator. So this is where you have to know the other way to do it. And the other way is by hand. So f of 1 equals 2 times 1 squared, which is 2 times 1, which is 2. And then f of x equals 2x squared. F of b equals 2b squared. Well, there's nothing to figure out, so those are your answers. Okay, so f of b is 2b squared. F of 1 is 2 over b minus 1. Now, I feel like I'm missing something. Find a value of b such as average rate of change from, oh, I forgot this part. I even highlighted it. So they are telling you what the answer is. They're telling you the average rate of change is 12. So you have to set this equal to 12. So this is definitely a more complicated one. This is probably the toughest one. This will be a double star. Okay, this is super tough. Definitely an 11th grade question for sure. Okay, at this point, all we can do, proportion, cross multiply. So 2b squared minus 2 equals 12 times b minus 1. Make sure to show me this line of work. I always want to see work when you multiply by a binomial. 2b squared minus 2 equals 12b minus 12. So you should know by now, we've done this a ton. If you see squared, you know it's a quadratic. You know you're getting it equal to 0. You know you're doing your t-chart and factoring and all that fun stuff that you love to do. So minus 12b plus 12 minus 12b plus 12. So why did I automatically move this and I didn't move left to right? You can't have a negative. So I'll move everything from the right to the left. So let's see, 2b squared minus 12b, those can be combined. I think it's plus 10 equals 0. So what kind of factoring do you always look for first? You always look for GCF. So is there a GCF? Yes. And that is 2. So b squared minus 6b plus 5 equals 0. And now I'm going to do MAMS. So b and B, drop down the first sign, multiply those two to get the second. All right, so M-A-M. What multiplies to 5 and adds to -6? What multiplies to 5? So it has to be 5 and 1. T-chart. 2 does not equal 0. B minus 5 equals 0. B minus 1 equals 0. Solve. B equals 5. B equals 1. Okay, so those are our two answers. Okay, those are our two answers. So what do we have up here? Find a value of B, such as the average change of, no, maybe this is of f of x from x1 equals 12. No, that's okay. So we already know that x1, okay, is 1. So that's not our answer. So we want to know what this value is, and the value is 5. So B equals 5. It's just the second number that we solved for. All right, hopefully you understood everything. If not, just let me know. But good luck on your homework. It's not too bad. Homework number 88, please just post that into Google Classroom when you are done so you get credit. All right, thanks so much. Bye.